Good day. Our project is titled Design and Simulation of an Intelligent Plant Watering and Soil Moisture Monitoring System using MATLAB Simulate. The main objective of this system is to automatically monitor the soil moisture level and activate watering only when necessary, ensuring that plants receive the right amount of water while minimizing water waste. The system is designed as a closed-loop control system, meaning it continuously checks the condition of the soil, compares it with a desired value, and makes decisions based on that comparison without requiring manual intervention. The Simulink model is composed of several key components, each representing a part of the real system. The integrator block represents the soil itself, where the moisture level changes over time. The constant blocks are used to define important parameters such as the desired moisture threshold and the drying rate, which simulates natural evaporation of water from the soil. The relational operator block acts as the controller or decision-making unit, comparing the current soil moisture with the set threshold. When the moisture levels falls below the threshold, the system recognizes that the soil is dry and produces an output signal to activate the pump. When the moisture level reaches or exceeds the threshold, the system automatically turns the pump off. The gain block represents the strength or rate of the water pump, determining how quickly water is added to the soil, while the sum block combines the effect of watering and drying to calculate the net change in moisture. The outputs of the system are displayed using scope blocks, where one scope shows the soil moisture behavior over time and the other shows the pump status. In operation, the system begins with an initial soil moisture value, for example is 30%. This value is continuously updated by the integrator based on the inputs it receives. The current moisture level is compared with the threshold, typically set at 40%. If the moisture is below this value, the controller activates the pump, allowing the water to be added to the soil, which increases the moisture level. At the same time, a drying factor continuously reduces the moisture to simulate real-world conditions. As the moisture level rises and reaches the threshold, the controller detects that sufficient water has been provided and turns the pump off. This process repeats continuously, forming a feedback loop that maintains the soil moisture within the desired range. Overall, the system demonstrates how an automated control system can intelligently manage plant watering. It is considered intelligent because it can sense the condition of the soil, make the decision based on predefined criteria, and adjust its action automatically. The use of feedback ensures that the system remains stable and efficient, preventing both overwatering and underwatering. Through this simulation, the project shows a practical and effective approach to improving water management in small-scale agriculture and gardening applications. The graph shows the soil moisture is maintained within a desired range, When the moisture level drops below the lower threshold, the system activates the water pump, causing the moisture to increase. Once the upper threshold is reached, the pump is turned off, and the moisture gradually increases due to natural drying. The cycle repeats, demonstrating an effective automatic watering system. So this is the block diagram for you to understand the flow of the project.